Despite being a relatively short topic, this one has huge applications later on. The skills that you develop here will be used for writing and evaluating chemical equations, a huge topic throughout AP Chemistry. And that's something that my students have had difficulty with in years past. By building these foundations now, you'll not only improve your performance in 1.8, but it'll help you throughout the rest of the year. The focus of 1.8 is on same group elements. A group is a vertical column on the periodic table, and every group shares three main properties. First, each has the same number of valence electrons. Take the noble gases, for instance. They all have a complete valence electron shell, and everything in the nitrogen group has 5 valence electrons. Since the common ions form based on the number of valence electrons, each element in a group also forms the same common ions. And the bonds between elements are also based on the number of valence electrons, so same group elements bond in similar ways. I remember all my science teachers from high school talking about how structure and function are connected, and it turns out they were right, because now I'm teaching it. Let me show you how this directly applies to the periodic table, because this is your reference guide that you're going to have with you on the exam. You better be able to see these concepts within the table. The valence electrons are also called bonding electrons. All you have to do is count across the s and p orbital groups. Remember that the d group is one energy level behind, so they're not valence or bonding electrons. The common ions you're expected to know for the exam are also based on the groups. You'll mostly need these as internal part of larger questions, so make sure you've got these down. If you were reading a book and every single line you read, you had to look up one of the words, you probably wouldn't understand what you've read by the time you got to the end of a single page. As you're working more complex problems later on, if you have to constantly stop and think about the smaller internal pieces, it's not really going to go well for you either. Unit 2 is all about bonding, but writing the chemical formula for ionic compounds is a 1.8 thing. And the questions you're likely to see on the exam relate to this same group elements forming similar compounds thing. If we take any group 1 element, take sodium for example, and we bond it to a halogen, watch what happens. Sodium and fluorine have equal and opposite charges, so when I put those together, the formula would be NaF. Since all these halogens have the same charge because they're in the same group, when they form sodium compounds, they're all going to form in this 1-to-1 cation-anion ratio. If we take something like lithium from that same group 1 and bond it to one of the halogens, it's also going to form this 1-to-1 cation-anion ratio. By the way, writing ionic compound formula, putting these cations and anions together, as well as breaking them apart into individual cation-anion pairs, is that piece that is going to come back over and over again throughout AP Chem. So make sure you practice this as you work through this section. Feel free to leave a comment down below if you need additional resources on this. I can see if I have enough time to put together another video or maybe some practice problems that might be helpful. These same group combinations work regardless of which group we're talking about. If I pair sodium with anything in the oxygen group, everything in that group is going to form a -2 ion, and so I'm going to need 2 sodiums to balance out the -2 charge, regardless of whether it's with the oxygen forming Na2O or the sulfur or selenium ions. Every single time I'm going to have this 2-to-1 cation-anion ratio. I can state this overall as saying that same group elements are going to form similar compounds. That cation-anion ratio will be fixed based upon the groups. Those are the 3 points, but recognizing them as I talk about each one isn't really good enough. These need to be ingrained in your understanding of the periodic table so that when you're working with more complex problems later on, you don't have to interrupt your train of thought to go back and think about all these simple things. Make sure you've practiced enough of this, and when this information jumps right off the periodic table at you, then you're ready to move on. Now, I need to ask a favor. Hitting that subscribe button really helps out me and my family. And although my main intention is to help and support you in every possible way, I do have ulterior motives with this YouTube stuff. So please do me a favor and hit that button. Thank you very much. And remember, don't just memorize it, understand it. I'll see you in the next one.